maximum size exists for a subpanel installed from a 100 amp service. According to the National Electrical Code, specifically Article 408.3b, the maximum permissible size for such a subpanel is 80 amps. This implies that the aggregate amperage of all circuits originating from the subpanel must not exceed 80 amps. To elaborate further, the National Electrical Code, or NEC, serves as the cornerstone for safe electrical installations. Article 408 addresses switchboards, switchgear, and panel boards, providing detailed requirements for their construction, installation, and protection. Specifically, NEC Article 408.3 deals with the rating and application of panel boards. Subsection B, which is relevant here, pertains to the overcurrent protection of panel boards. The rule stating that a subpanel connected to a 100 amp service cannot exceed 80 amps stems from the necessity to protect the main service and the subpanel itself from overloads. It is crucial to understand why this limitation exists and how it impacts electrical system design. The 80 amp limitation is not arbitrary. It reflects a safety margin designed to prevent the 100 amp main service breaker from tripping unnecessarily due to sustained high loads on the subpanel. This is closely tied to the concept of continuous loads, which are loads expected to operate for 3 hours or more. The NEC stipulates that overcurrent devices such as circuit breakers should be rated at 125% of the continuous load. This means that an 80 amp breaker can handle a continuous load of 80 amps multiplied by 0.8, which equals 64 amps. The calculation is as follows. A load breaker must be rated 125% of continuous load, and that number cannot exceed the amperage rating of the feeder or service. So 100 amp divided by 1.25 equals 80 amps. Therefore, the maximum size breaker that can be installed to feed a subpanel off of a 100 amp service is 80 amps. This 80 amp limit applies to the main breaker in the subpanel if it is one, or the sum of the overcurrent protection of the individual circuits connected to the subpanel. The 80 amp requirement is a maximum, so the size of the subpanel can be smaller if required. If the anticipated load of the subpanel is very small, then there is no need to use the 80 amps. Consider a subpanel in a small workshop. If only needing 20 amps for small outlet and lighting circuit, there is no need to install the 80 amps. When sizing electrical components, including subpanels and their feeders, adherence to the NEC is paramount. The NEC specifies ampacity requirements for conductors, which are based on the load they will carry and the type of insulation they have. The ampacity of a conductor refers to the maximum current, in amps, that it can carry continuously under specified conditions of use without exceeding its temperature rating. Conductors must be sized to handle the anticipated load, considering both continuous and non-continuous loads. Continuous loads, as mentioned before, are loads that are expected to operate for 3 hours or more. Non-continuous loads are those that operate for less than 3 hours. Conductors must be protected against overcurrent by fuses or circuit breakers. The overcurrent protection device must be sized to protect the conductor, but it should not be larger than the ampacity of the conductor. In the context of a 100 amp service feeding an 80 amp subpanel, the conductors feeding the subpanel must have an ampacity of at least 80 amps. The overcurrent protection device protecting these conductors must also be rated at 80 amps or less. The selection of appropriate conductors and overcurrent protection devices is crucial for ensuring the safe and reliable operation of the electrical system. Undersized conductors can overheat, leading to insulation breakdown and potential fire hazards. Oversized overcurrent protection devices can allow excessive current to flow through the conductors, also increasing the risk of overheating and fire. Therefore, it is essential to carefully calculate the load requirements and select conductors and overcurrent protection devices that meet the NEC requirements. The calculation of load requirements involves determining the total amperage of all the devices and equipment that will be connected to the subpanel. This includes lighting, receptacles, appliances, and any other electrical loads. The NEC provides guidelines for calculating the load requirements for various types of occupancies and equipment. These guidelines take into account factors such as the square footage of the space, the type of occupancy, and the number and type of appliances and equipment. Once the load requirements have been determined, the appropriate size conductors and overcurrent protection devices can be selected. The NEC provides tables that list the ampacity of various types of conductors based on their size and insulation type. These tables also specify the maximum overcurrent protection allowed for each conductor size. To determine the correct wire size, NEC Table 310.15b16 is generally used, unless directing factors apply. This table provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, based on the conductor's insulation type and temperature rating, and the ambient temperature. For example, if using type DHHN copper conductors with a temperature rating of 90 degrees Celsius, the table indicates that an 80 amp circuit would require a minimum of number 4 American wire gauge AWG copper conductors. However, it's essential to consider any applicable directing factors, such as those for ambient temperature, conductor bundling, or conduit fill. These directing factors can reduce the allowable ampacity of the conductors, requiring a larger wire size. After determining the proper wire size, select the proper size breaker. As stated earlier, this is determined by the conductor size, but is also dependent on the load. For example, a number 4 AWG copper conductor with THHN insulation is rated for 85 amps at 75 degrees Celsius per NEC Table 310.15b16. A standard size breaker equal to or less than this ampacity will need to be selected. As the maximum subpanel size off of a 100 amp service is 80 amps, a breaker equal to or less than 80 amps is to be selected. Once the conductor and breaker is properly selected, the method of installation should be considered. This includes how the wiring is run back to the main panel, the type of conduit used, and the ambient temperature the wiring will be subjected to. It should also be ensured that the grounding and bonding requirements of NEC Article 250 are met. Grounding ensures a low impedance path for fault current to return to the source, which allows the overcurrent protection device to operate and clear the fault. Bonding connects all metal parts of the electrical system together, creating an equipotential plane that minimizes the risk of electric shock. The installation also must comply with the working space requirements of NEC Article 110.26. This article specifies the minimum clear working space required in front of electrical equipment, such as panel boards, to allow for safe operation and maintenance. The working space must be clear of obstructions and must have adequate lighting. Furthermore, the subpanel itself must be properly labeled and identified. The NEC requires that all electrical equipment be marked with its voltage, current, and power ratings. The subpanel must also be labeled to indicate the source of power and the circuits it serves. Proper labeling helps to ensure that the electrical system is safe and easy to maintain. It is also important to note that the NEC is not a static document. It is revised and updated every 3 years to reflect changes in technology and industry best practices. Therefore, it is essential to stay up to date on the latest NEC requirements. When installing a subpanel, it is always a good idea to consult with a qualified electrician. A qualified electrician can help you to determine the load requirements, select the appropriate conductors and overcurrent protection devices, and ensure that the installation complies with all applicable NEC requirements. The 80 amp subpanel limitation is a crucial safety measure to prevent overloads and ensure the integrity of the electrical system. Neglecting this requirement can lead to potentially dangerous situations, including overheating, fire hazards, and equipment damage. In addition to the 80 amp limitation, there are other factors to consider when installing a subpanel off of a 100 amp service. Firstly, the subpanel must be properly sized to accommodate the anticipated load. The subpanel should have enough spaces for all of the circuits that will be connected to it. Secondly, the subpanel must be properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. Thirdly, the subpanel must be properly labeled. Labeling helps to identify the circuits that are served by the subpanel. This makes it easier to troubleshoot problems and to make changes to the electrical system. Fourthly, all wiring must be done in accordance with the NEC. The NEC is a set of standards that provides guidelines for the safe installation of electrical wiring. When a subpanel is fed from a mains service, it effectively extends the electrical distribution system. This extension requires careful coordination and adherence to safety standards to ensure the overall system's integrity and reliability. Firstly, the location of the subpanel must be carefully considered. It should be readily accessible for maintenance and repairs, yet protected from physical damage and environmental hazards. The NEC specifies minimum clearances around electrical equipment to allow for safe working space. Secondly, the subpanel's enclosure must be appropriate for the environment in which it is installed. For example, in damp or wet locations, an M3R or 4 rated enclosure may be required to protect the subpanel from moisture. Thirdly, the conductors feeding the subpanel must be properly protected from physical damage. This can be achieved by using conduit, raceway, or other approved methods. The NEC specifies the types of wiring methods that are permitted in various locations. Fourthly, all connections within the subpanel must be made using approved methods and materials. Connections must be tight and secure to prevent overheating and arcing. The NEC provides detailed requirements for making electrical connections. Fifthly, the subpanel must be properly supported and secured. It should be mounted to a wall or other structural member using appropriate hardware. The NEC specifies the requirements for supporting electrical equipment. The purpose of these requirements is to ensure that the subpanel is installed safely and reliably. By following these requirements, the risk of electrical hazards can be minimized. In addition to the technical aspects of installing a subpanel, it is also important to consider the permitting and inspection requirement. Most jurisdictions require a permit to be obtained before installing a subpanel. The permit process typically involves submitting plans and specifications for the installation to the local building department. Once the permit is approved, the installation can begin. After the installation is complete, it must be inspected by a qualified electrical inspector. The inspector will verify that the installation complies with the NEC and all other applicable codes and regulations. The inspection process helps to ensure that the electrical system is safe and reliable. In summary, installing a subpanel off of a 100 amp service requires careful planning and execution. The 80 amp limitation must be strictly adhered to, and all other applicable NEC requirements must be followed. It is always a good idea to consult with a qualified electrician to ensure that the installation is done safely and correctly. By taking these precautions, the risk of electrical hazards can be minimized and the electrical system can be operated safely and reliably. It is also important to keep in mind that electrical work can be dangerous. Only qualified individuals should perform electrical work. If you are not qualified, it is best to hire a qualified electrician to do the work for you. This will help to ensure that the work is done safely and correctly. The NEC guidelines and local codes are always changing. Be sure to follow the latest updates. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. The local codes may also have additional requirements that must be followed. By following the NEC and local codes, you can help to ensure that your electrical system is safe and compliant. Electrical work is dangerous and deadly. Please call a professional. When planning to install a subpanel off of a 100 amp service, consider the long-term electrical needs of the space it will serve. This involves anticipating future load increases and ensuring that the subpanel has sufficient capacity to accommodate them. If there is a possibility of adding more circuits or increasing the amperage of existing circuits in the future, it is wise to install a subpanel with more spaces and a higher amperage rating than initially required, within the 80 amp limit. This will avoid the need to replace the subpanel later on, which can be costly and disruptive. It is also important to consider the type of loads that will be connected to the subpanel. Some loads, such as motors and HVAC equipment, have high inrush currents that can briefly exceed their rated amperage. The subpanel and its overcurrent protection devices must be sized to accommodate these inrush currents. The NEC provides guidelines for sizing overcurrent protection devices for various types of loads. Furthermore, the subpanel's location should be chosen to minimize voltage drop. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for minimizing voltage drop. The length of the circuit, the size of the conductors, and the load current all affect voltage drop. By carefully considering these factors, the subpanel can be located in a way that minimizes voltage drop. When selecting a subpanel, choose a reputable manufacturer and a quality product. A well-built subpanel will provide years of reliable service. Look for features such as a sturdy enclosure, high-quality circuit breakers, and clear labeling. Also, be sure to choose a subpanel that is listed by a recognized testing laboratory such as Underwriters Laboratories or Intertek. This listing indicates that the subpanel has been tested and meets safety standards. As technology evolves, electrical systems are becoming more complex. Smart homes, electric vehicles, and renewable energy sources are all placing new demands on electrical systems. When planning to install a subpanel, consider how these technologies may impact the electrical needs of the space. For example, if you are planning to install an electric vehicle charger, you will need to ensure that the subpanel has sufficient capacity to handle the additional load. You may also need to install a dedicated circuit for the charger. Similarly, if you are planning to install solar panels, you will need to ensure that the subpanel is compatible with the solar power system. The NEC provides guidelines for installing solar power systems. It's important to keep the panel's interior clean and free of obstructions. Dust, debris, and moisture can accumulate inside the panel, potentially causing malfunctions or safety hazards. Regularly inspect the panel's interior and clean it as needed. Also, ensure that there are no loose wires or connections. Loose connections can cause overheating and arcing, which can lead to fires. Tighten any loose connections and replace any damaged wiring. Also, make sure the panel door is properly secured. A loose or damaged panel door can allow access to live electrical parts, which can be extremely dangerous. Repair or replace any damaged panel doors. Following these maintenance tips will help to ensure that the subpanel operates safely and reliably. Remember that safety is always the top priority when working with electricity. If you are not comfortable performing electrical work, hire a qualified electrician. A qualified electrician has the knowledge and experience to perform electrical work safely and correctly. Working with electricity can be dangerous and deadly, so it is important to take all necessary precautions. Be sure to turn off the power before working on any electrical equipment. Wear appropriate personal protective equipment, such as safety glasses and gloves. Use insulated tools. And never work on electrical equipment when you are wet or standing in water. By following these safety tips, you can help to prevent electrical accidents. The maximum subpanel size for a 100 amp service is a critical safety consideration that ensures the electrical system operates within its design parameters. By understanding the NEC requirements and adhering to best practices for installation and maintenance, electrical systems will operate safely and reliably. Remember, always prioritize safety and consult with qualified professionals when dealing with electricity.